Hey everyone, this video is just going to be a little bit of extra help in solving these trigonometric identities here and simplifying these expressions. In this worksheet, you are going to need to simplify each of these to a single trig function or a constant, and your options are down here. These can be used more than once. You'll notice there's 10 answers and there's 12 questions. So again, can be used more than once. When you get an answer, you will then match it up with down here. So we're going to actually do at least one of them, and I'll demonstrate how this works. Some of these are a bit challenging. I'm not going to try to tell you they're easy. They can be definitely challenging. You might need to work through them a couple different ways and try to figure it out. Make sure you're doing that. Make sure you're submitting all of your work. Even if you can't figure out, I need to see a lot of work where you try to do that. So we're going to do, first of all, the most challenging one, which is number 11. I'm going to do that with you. You can maybe apply some of these principles to future problems on here as well. So let's go ahead and do number 11. You'll notice that this is something that needs to be FOILed, right? It's two sets of parentheses here, so we got to do our first outer and our last distribute through. All right, I'm going to write it off to the side over here. So we do cosecant of theta times 1 is just cosecant of theta. Cosecant of theta times negative cosine of theta. That would be minus cosecant theta cosine theta. We then need to do our n side. Cotangent of theta times 1 will just be a plus cotangent of theta. And lastly, cotangent times minus cosine is minus cotangent theta cosine theta. All right, so we got a bunch of stuff here. Now, next thing let's do is our strategy of converting everything to sines and cosines. So cosecant, that is 1 over sine of theta. Hopefully most of these are getting to be a little bit more stuck in your brain. You just know it without having to look at your sheet there. Minus, now this I'm going to write in parentheses because we're going to multiply it. 1 over sine theta times, and we can actually just leave this as cosine of theta for now. Right? Plus cotangent is going to be cosine of theta over sine of theta. Minus another cotangent is cosine of theta times sine of theta times cosine of theta. And if it's helpful, you could even write this over 1 and this one over 1 as well. All right, let's see what we get from there. So let's go ahead and write this as 1 over sine of theta minus, and I'm just going to go ahead and multiply these two and write it as cosine of theta over sine theta plus, for now we'll just leave this as cosine theta over sine theta. And when we do this last one here, when we multiply this on the top, so we get cosine times cosine, that's going to be cosine squared theta over sine theta, just multiplying by 1. And now what you'll notice is something that we must have. So all fractions, remember, we need a common denominator. So if there is a case where you don't have a common denominator and you need to add and subtract fractions, you need to get one. This works out so that there is a common denominator, so that's good news for us. So what we can then do is we can just actually combine these all together. So all the numerators, we just add the numerators and we keep the denominators. So we got 1 minus cosine theta plus cosine theta minus cosine squared theta. See, all the numerators there can add together, add and subtract them, and then just put them all over the same denominator, because all of our denominators are sine. Okay, from there, let's see what cancels. Well, we got a minus cosine and a plus cosine, so those wipe out. Now, I've got just 1 minus cosine squared theta left over sine of theta. And hopefully that 1 minus cosine squared theta looks familiar. That's the same thing as sine squared from our other trig identity. So this is sine squared theta over sine of theta. Now this is good because a sine over a sine, well, those would cancel in the same way that if we had like an x squared over an x, well, the x would just cancel and it leaves us with just a sine theta. I know I made that look probably kind of easy. It's not supposed to be that easy for you, so don't get discouraged if it's not that easy for you. But I do want to show you how this can all work out here. They're not always short and easy. Sometimes you got to work through these. You will eventually get down to a single trig function. There also is not one, there's not just one way to do these problems. There's different ways to go about it. So if you get it, same answer, but doing a different way, by all means, that's great. All right, so now we find the match. So the match we had was sine theta, which is right here, and that corresponds with a u. So that was problem number 11. So I'm going to go down to the 11 blank down here, put a u. Okay. So after you've done all 12, it will answer the question. On October 4th, 2006, Akira Haraguchi broke his own record by reciting the number pi to 100,000 decimal places. It took him over blank blank to complete the task. So you will figure that out if you get through all of these. Let me just show you maybe another one to do here. On most of these, like so on number 9, you're going to want to FOIL this one again, like we just did. On number 12, it looks like you're going to want to FOIL a bit, but look for a shorter cut, if you will. Try to find a shorter cut. Try to find a shortcut, meaning replace both of these. Replace this and replace this. Replace those whole things with something easier. And hopefully that makes sense. You will need to, like a number 6, distribute there. And then simplify. Let's see, maybe we'll attack one more together where you need a common denominator. Which one do I want to do? All right, sorry about this. Let's do number 2. I'm going to show you number 2. All right, so number 2, you're going to go about strategy, make everything sines and cosines probably. Sine of theta plus cosine theta over sine theta over cosine theta, right? And what you'll notice here, we'll get sine of theta plus cosine squared theta over sine theta when we multiply, right? Because cosine times cosine is cosine squared. We need to add these together. You'll see, right? We need to add these together. But this one, the first one, is actually just over 1. So we can't add these together without a common denominator. So what we actually want to do is to get that common denominator is, well, we're going to multiply this one times sine of theta over sine theta. And we can do that because sine over sine is just 1. And now by doing that, it'll give us a denominator of sine theta. So we get then sine squared theta on top over sine of theta plus cosine squared theta over sine of theta. So I just changed that first one to give it the same common denominator. I can then add the numerators, sine squared theta plus cosine squared theta over the one denominator. We then know that sine squared over cosine squared is actually just 1. So 1 over sine theta. We don't want to leave it like that because there's one more we can do to make that a little bit better. 1 over sine theta is equivalent to cosecant theta. So that will be our answer to number 2. So you can plug that in and finish the rest. Again, do your best on these. Some of them are easy, some of them not so easy. But do the best that you can. Number 6, you will actually have to do a very similar, after you distribute, you have to do a similar thing that we just did to number 2. Similar idea. So do your best on those guys. Reach out to me if you're really struggling. At least show a lot of your work and try to figure out at least half of these would be great. If you are really struggling, you can't figure out 1 or 2 of them, no big deal. Show me your work and you'll be good to go. All right, good luck on that.